All right, guys, we are going to talk about meat production methods. And so, what, sorry, I was distracted by the thing on my screen. Anyway, we're talking about meat production methods, which is 5.7. So, um, there's a lot of essential knowledge that you need to gain in here, but we will go through it for sure. You need to be able to identify the various ways that we have in the United States and around the world of producing meat, and then you need to be able to identify both the benefits and the drawbacks of each of those various types of meat production. So the first thing that you need to be aware of are things called CAFOs. So CAFO stands for Concentrated Agricultural Feeding Operations. These are what you might know as feedlots. And so these are really densely crowded areas where cows, pigs, chickens, typically they're fed grains, and the goal is to raise them as quickly as possible, because if we raise them quickly, we're going to make more money. So this is just an example of where cows are being raised in a feedlot here. You might raise them in this feedlot, one, because it's going to maximize land usage. So instead of putting the cows out to pasture and letting them roam all around and then having to corral them back up, it's a really efficient use of land. And then we're going to get the most meat basically per unit area if we put them in these feedlot operations. It also means that we can produce meat at a cheaper price for the consumer. So it costs a lot less to raise or raise animals for meat in a CAFO operation than it does to put them on out to a field and grazing in a field. So one of the drawbacks to this type of operation is that because they're so tightly packed together, it really requires the use of antibiotics to prevent any spread of disease. And then because we're trying to turn over these organisms as quickly as possible, we're giving them growth hormones to speed up the production of the meat. And then one of the other drawbacks is that when you concentrate animals like this, you're producing extremely large volumes of waste. So both fecal matter and urine, and that gets collected and then can eventually contaminate nearby surface or groundwater. When they're spread out in a field, it can fertilize the field, but in high concentrations, like we're showing here, it's not fertilizing the field. There's nothing growing on the ground in these areas. And then it also produces really large amounts of carbon dioxide, methane, and nitrous oxide, which are all greenhouse gases and can all lead to or intensify climate change. So a little bit more about these manure lagoons. These are these large, open, essentially storage areas where you're going to take the waste from these chicken houses, perhaps, or whatever else, their hog houses, and you're going to pump the waste products through pipes into these manure lagoons. And so the waste from these organisms contains ammonia, which is a very concentrated source of nitrogen. It contains any hormones that you've fed them, growth hormones. It contains the antibiotics because the body doesn't process all of the antibiotics, so some leaves through waste products. And then it also contains fecal coliform bacteria, which you may know or kind of associate more with something called E. coli, which is not good for humans. So what happens, it's fine typically to concentrate this in these manure lagoons, but if there's a heavy rainfall, we can have manure lagoons that flood or overflow. And if they overflow, they're going to contaminate nearby surface water. So if there's a river or a lake nearby, or they can just spill over and then contaminate groundwater sources in the area. And so E. coli is toxic to humans. The ammonia that's going to be in those manure lagoons can lead to eutrophication. And then those antibiotics and the growth hormones that are given to the animals to alter their hormonal system can also, if consumed by humans, can alter our endocrine system. And so they can disrupt the endocrine system. They can cause all kinds of issues with reproductive systems. And then the other thing is that, remember, in the nitrogen cycle, we have the process where we have ammonia and ammonium, and then those denitrifying bacteria can break that ammonia and ammonium down. And then when they do that, they're releasing nitrous oxide back to the atmosphere. And nitrous oxide is a very powerful greenhouse gas. So one of the good things, though, I've told you a lot of bad things. One of the good things is that these manure lagoons can be emptied so that they are less apt to overflow and contaminate surface or groundwater. And so that waste can be buried in a landfill, or that waste, you can take all the water, you can essentially dehydrate the waste and then turn it into fertilizer pellets that can then be used on farm fields to grow crops and prevent the use of synthetic fertilizer. So the other option, or the alternative to raising animals in a CAFO, is free-range grazing. So typically we associate this most with cows. And so if they're free-range cattle, they're going to graze on grass. They're going to grow at a natural rate. We're not giving them growth hormones. They're spread out enough so that we don't need to give them antibiotics to keep diseases down low. And so this would be an example, kind of pastoral picture of cows in a field. And that's exactly what free-range grazing is. So like I said, there's no need for antibiotics. It doesn't require corn. So typically if we're using a feedlot, we then have to grow corn to feed the cows. And so we're needing land to grow the corn and then feed the cows. Whereas here, they're grazing on the grass that is growing naturally in the fields. And then waste is not concentrated in these free-range grazing operations because the cattle roam around and deposit their waste, and it's acting like fertilizer instead of being concentrated and then building up in these manure lagoons. The problem is that it requires a lot more land to free-range graze cattle. And so because it requires land, it is more expensive to raise and grow and produce free-range meat. So that cost gets passed on to the consumer. Animals can graze on the land that is typically too dry to even grow crops. So it's another win in terms of, hey, this land really can't be used to grow anything else, but it can be used to graze the cattle. One of the problems that can come from free-range grazing is that there can be overgrazing. And so this picture kind of represents that very clearly. On the right, there have been no cows grazing, and on the left, there have been cows grazing. And so if you don't rotate where the cows are grazing, they can remove all the vegetation. And then once the vegetation is removed, you can have topsoil erosion. Also, you can, if it's overgrazed and the animals aren't rotated in and out of fields, you can have lots of compaction of the soil. And if the soil is compacted, it doesn't hold water as well. If it doesn't hold water as well, it's drier. And so you get increased amount of erosion. And then kind of the ultimate problem that can lead from overgrazing is this idea of desertification. And so if the plants get killed by this process of overgrazing and the soil is too compacted and stuff can't grow anymore, now all of a sudden what was a pasture or what was a grassland is now turning into a desert. So the ways to fix that is just by rotating the animals periodically, and you can prevent overgrazing. And actually what's interesting is that it also helps the plant growth if you and the root growth and the resilience. So if you rotate the animals, you're going to get much better, more resilient, deeper rooted grasses in your fields, which is only going to continue to help feed your cattle. And if you're rotating the cows, we're distributing the nutrients, and so you're using that natural fertilizer and helping plants to grow that way as well. So here is just another kind of look at this. So it actually turns out that by occasionally cutting the grass or having cows eat the grass, it actually can increase the growth rate of grass. So one of the things to be really mindful about, and that the AP examiners often ask about, is like why you should eat lower on the food chain, or why it's more energy efficient or more environmentally friendly to eat lower on the food chain. And basically the idea is that producing meat for humans to eat is far less efficient than producing plants in terms of both energy usage and land usage, right? So all of the energy needed to plant, grow, harvest the plants, to feed the animals, we have to take into consideration. Plus, you have to look at the energy that is needed to bring water to those animals, the energy that's needed to house those animals, in some places to cool those animals if they're grown in warmer climates, the energy needed to slaughter and package the animals. And so if you look over here, the energy required to produce a single pound of any of those things, lots and lots of energy required to produce beef or pork or even cheese is higher here than chicken, versus corn or apples, much less energy required. Plus all the land, all the energy needed to grow the plants and feed the animals, plus all the room that the animals take up. And so you can kind of look here, usable protein per acre of farmland. Soy is the way to go in terms of protein versus beef, which is way down here. And then water. You have to think about all of the water, not only for the crops that the animals eat, plus the water that the animals actually have to drink themselves. And so if you look at water usage, again, obviously your animals are much higher water usage up here than if we're just eating vegetables. So what I'd like you to do is to explain an environmental benefit of eating a plant-based diet rather than a meat-based diet, and use the data here in this picture to help support your argument.